In coordinate geometry, we have the midpoint formula. You might be wondering, how is the formula being derived? In this video tutorial, I'm going to show you. So let's begin our discussion with the coordinate plane. Along the vertical part of the coordinate plane, we have what we call the y-axis, sometimes known as the ordinate, while along the horizontal part, we have the x-axis, which is sometimes known as the abscissa. Now let's consider a point P within the plane. You notice that the corresponding point along the y-axis of point P will be this, and assuming that is y1. Then along the x-axis, that will be this. Then let's take for instance, that is x1. Now consider an object at this point P. If the object changes its position all the way to point Q, what would have been the distance moved by the object in both axes? You notice that the object has now moved a distance known as x2 along the x-axis, while it has now moved a distance known as y2 along the y-axis. Perfect. Now, what if you are asked that what is the distance between point P and Q? You notice that that will just be the distance between, and that will just be this. So that will be the distance between point P and Q. Now we can clearly see that point P and Q has now formed a right angle triangle. Apart, let me use a straight line. Perfect. Now, what if we are willing to find the midpoint of this line PQ? What are we to do? You notice that the midpoint of this line PQ, if we estimate it properly, it will be somewhere around here. However, we need to find the exact value. Now, on a coordinate plane, all points has its corresponding x value and its corresponding y value, which implies that if we assume this point is point C, then it's going to possess its corresponding value along the x-axis, likewise its corresponding value along the y-axis. And whatever value x and y is, that will tell us the midpoint of line PQ. So now our main goal is to solve for x and y. So what are we to do? Let's move on. Now what I would like to do is to determine the distance between point P and C along both the axes. You notice that along the x-axis, the distance between point P and C will be from here all the way to this point. And the distance between point P and C along the y-axis will be from here all the way to this point. Perfect. So let me just use the right angle triangle idea to do that. So that's going to be this. Perfect. Whereby the red line tells us the distance between point P and C along the y-axis. And if we are to determine that, you can clearly see that that will be given as y minus y1. So what does that mean? It means the difference between the maximum point along the y-axis, which is y, and the difference and what the minimum point along the y-axis, which is y1. So that's how I got y minus y1. And along the x-axis, that's just going to be x minus x1, because the corresponding value of this line is simply x. That's how we got x right here. And the corresponding value of this is simply y. Very good. I hope you are getting how I'm interpreting everything one after the other. So now, just like what I did to point P, I will repeat the same process to point Q. What would have been the distance between point C and Q along both axes? You notice that that will be this. Let me use a straight line. So along the x-axis is going to be this, and along the y-axis is going to be this. Perfect. So now we can clearly see that since the maximum point along point Q is y2 and its minimum point is y, that is along the y-axis, then the distance will simply be y2 minus y. And since the maximum point along the x-axis of point Q is x2 and its minimum point along the same axis is x, then it means its distance is going to just be x2 minus x. Perfect. So now let's apply some of our knowledge in geometric, because we can, at this point, we just need to make some arrangements. What can we say about these two triangles? Triangle PC, let me assume this is A and this is B. What relationship? What is connecting triangle PCA and triangle CBQ? What can you say about that? Now, before we can draw out any conclusion, let's try to make some amendments. You notice that if line YB is a straight line and it tends to be parallel to line Y1, so let me assume it is C. Okay, I've used C before, let me assume it is G. If line YG is also, let me get rid of this. If line YG is also a parallel line, as you can see, it's a straight line. You notice that YB and YG can never meet, and they are moving towards the same direction. Then we can clearly see that they are parallel lines. But what about Y sub 2 and Q? This line is also parallel to the following lines, that is YB and Y1G. So therefore, line PQ is serving as a transversal line to the three parallel lines. And at this point, we can just find some angles that are equal. Now, according to Euclidean geometry, the corresponding angle are equal. Likewise, the alternate angle. However, we'll be using the corresponding aspect in this video to solve this problem. Now, we can clearly see that this angle right here, let me use different color so you can clearly see that this angle will definitely be equal to this angle. Why? They are corresponding to each other. Angle made within the parallel line will be equals to the same angle outside the parallel line along the same direction. That's what it means by corresponding angle. So this is parallel line, this parallel line YB, this parallel line Y1G, and this is a transversal line. So you can clearly see that this angle and this angle are equal according to the corresponding theorem. So let me just write that statement over here, that triangle QCB is equals to angle CPA. That's angle CPA. Angle CPA. Why? They are corresponding to each other. Perfect. Now, what about angle CQB? And that's angle PCA. What can you say about them? We can clearly see that they are going to be equal to each other as well, because they are corresponding to each other. However, not due to the fact that they are being subtended by the same parallel line, because for these angles, these two red lines is serving as the parallel lines. You can clearly see it, and this now is the transversal. So this is the angle made by that parallel line outside, and this is the angle made inside. So therefore, they are going to be equal to each other. Now, if angle CQB is equals to angle PCA, now we can use some of the knowledge in congruent triangle to set that their corresponding side will definitely be equal. Using the postulate angle, side, angle. since the angle and these two angles are equal and these two angles are equal. So you might be wondering, where is the side coming from? This is the side. Why? Because PC will definitely be equal to CQ, since point C intercepts PQ. Definitely they must be equal to each other. So therefore, this angle PC must be equal to angle CQ. And therefore, we can use the postulate of of congruent triangles to show that these two triangles PCA and CBQ are equal. And if that's the case, the corresponding side is going to be equal. So therefore, at this point, x minus x1 can now be equals to x2 minus x. And if I bring x to this side, I can clearly see that x plus x, if I take this, will now be equals to x2 plus x1. And at this point, 2x will be equals to x2 plus x1. And if I divide both sides by 2, x will be equals to x2 plus x1 divided by 2. And this is how to get the coordinates of that midpoint along the x-axis. Perfect. Now, what about that of y-axis? Let's see that as well. So that's just going to be y minus y1 will be equals to y2 minus y. So if I repeat the same process like what I did earlier, so that's going to be y plus y equals y2 plus y1. 2y will be equals to y2 plus y1. And y will be equals to y2 plus y1 all divided by 2. And this is how to get the corresponding coordinate of the midpoint that intercept a particular line on a Cartesian plane. Hopefully you find this content helpful. If you haven't subscribed to my channel, please do subscribe to my channel. Also, you can always share the video with your loved ones and wherever you think it will be of use to. So now I would like to solve a certain problem, a particular problem, just for example, for you to see how this proofs really works. So let's consider 2 points on a Cartesian plane. Point P to consist of the coordinate 2, 3 and point Q to have the coordinate 5, 4. What will be the coordinates of the midpoint of the line that is joining point P and Q? To get that, you get the x first. That will be, this will just be your x1, this will be your y1, this will be your x2, this will be your y2. So that will be, for the x-axis, that will be x2 plus x1 all divided by 2, and that will be indeed equals to 5 plus 2 all divided by 2, and that will be 7 over 2. And along the y-axis, that will be y2 plus y1 all divided by 2, and that will be indeed equals to 4 plus 3 divided by 2, and that's 8 over 2, which is indeed equals to 4. And that's how to use these proofs to solve a problem that is involving finding the midpoint formula. Thanks for watching. See you guys in the next video. So you can use this as practice problem if you have point A to consist of minus 3, minus 5, and you have point B to consist of 7, 9. Find the coordinate of the midpoint of the line joining point A and B together. Thanks for watching. See you guys in the next video. Bye for now.